Okay. So we're going to try to pick up and wrap up and totally finish this discussion on inheritance. Just to do a quick review, we have parent class and child class. Parent class is superhero, and it has some private instance variables. It has a default constructor, a custom constructor, a toString, and some action methods, as well as some gets and sets. And we have the child class or the subclass Marvel Hero, which has its own private instance variable, comedic level. It has a default constructor, custom constructor, its own method called attack, and its own method called toString. And the attack method overrides the parent attack method. The toString overrides the parent method of the same name. However, in both of those cases, it calls the parent method, or the method of the same name in the parent class, because it wants to utilize some of that functionality. Okay. Also, we talked about the constructors here. The constructor, the default constructor, and the custom constructor call the parent class's constructor. And what was that keyword that accesses the parent class? Super, right. Unrelated to the fact that the parent class name is superhero. But anyway, so just a super, and then we've got that. And we talked about when in our superhero, that is the parent class, when these variables are private, they are inherited, but they are not accessible by the child class. So the child, the rule was the child cannot access the parent class's private instance variables. They have those values, and they're present within them, but there's no way that they can directly access them. So what was the tool that the child class made use of to be able to access or to change those values? It was not super. It was the gets and sets, which are publicly visible. Okay, that private keyword, man, that locks everybody out, even your children. But those were inherited. It's sort of it's an interesting phenomenon. Those instance variables are inherited, but they're not accessible when they're private. That is, okay. So, what I want to talk about here is some interesting phenomenon, namely, let's talk about this comedic level. We had, there was an int comedic level property here in the Marvel Hero. And in our Earth example, we had Superhero S1 and S2, Marvel Hero M1 and M2. We would say that, so we've got Superhero S1 pointing to a superhero object, Superhero S2 pointing to a superhero object, M1, M2, and we would say that M1, or more specifically, I guess we could say class names. We could say the Marvel Hero is a superhero. And we could say the Marvel Hero has a comedic level. This is some terminology that we see in computer science, the is-a and has-a relationship, okay? The has-a relationship basically means that this thing over here is an instance variable inside the class, okay? Now this happens to be an int, but we could have other things. We could have like strings and doubles and booleans and stuff like that. We could even have a class inside here. We could have a class called, I don't know, well, I mean, string is a class. We could have a class, you know, and it would say it has a name or whatever. But that's the has a relationship. We've been dealing with that for quite some time. The is a relationship is a reference to this inheritance property, where Marvel Hero is a superhero. And the way we designate that, if you recall, was through that extends keyword. Okay? So, just something to keep in mind. That's something that we see. That's not big of a deal. Something else. Because of that relationship, because the Marvel Hero is a superhero, I want to talk to you about, now that's interesting that that's sort of showing up all over this. This line right here, superhero S1 equals new superhero, okay? That word right there, when you see the superhero there, that indicates that S1, this variable, is of type superhero. And it essentially creates this part right over here to the left here, okay? So this S1 is a variable, and it can point to anything that is a superhero. So it can point to superheroes. M1 is a variable of type Marvel Hero, which means it can point to Marvel Heroes. I'm just going to put MH. Okay? Now, this leads us to yet another rule of inheritance. Okay? And you probably experienced it for yourself if your parents have ever had a conversation with you. Okay? And that deals with pointing. All right? Have your parents ever said this to you, or you've heard somebody else's parents say that? Don't point your finger at me. Have they ever said that to you?
Yeah.
Or you heard somebody say that? Now, interesting fact. What are they doing when they're saying that to you? Don't you point your finger at me. Am I right? Am I right?
Yeah.
They're pointing at you. So wait a second. So it's okay for your parents to point their finger at you, but it's wrong for you to point it at them? I don't know. Well, it's just the way it is. That's the way it is with families, and that's the way it is in Java as well. A parent variable can point to a child object. Let me say that again. A parent variable can point to a child object. Why? Well, according to this, S1 can point to anything that's a superhero, right? Here I have a Marvel Hero object. Is that a superhero? Yeah, it is. It extends the superhero class. Everything is true of superheroes is true of this Marvel Hero. So, if I wanted to, I could make S1 point to M1. And that's what I'm going to do. S1, at the very end here, I'll say S1 equals M1. And so now, superhero S1 is pointing to M1. And if I look at M1, M1 was our, maybe I should make it point to M2. That's Elastigirl, that's our custom one. I think I kind of like that idea a little better, so. Elastigirl, her superpower was stretchy.
Yes.
So if I say system.out.println S1, it should be printing or pointing to Elastigirl. And now hold on, let me make S1 point to M2. So that rule, once again, parent variables can point to child object. I mean, that's really not the most accurate technical grid. It should say, parent reference variables can reference objects which are instantiated from a child class of that parent. But whatever. I'm trying to make it a little bit more succinct so you can memorize it. Parent variables can point to child objects. Okay? Now, can child objects point to, can child variables point to parent objects?
No.
Alex says no. My parents would say no. All right? If I go over here and if I say M1 equals S2, it's going to throw me an error. Type mismatch. Cannot convert from superhero to Marvel hero. Okay? I cannot. This M1 is the Marvel. Remember the child. The child cannot point or reference a parent object. Okay? So not vice versa. Sorry. But that's
Because the child can't become a parent.
the child can't point to the parents. Child can't reference parents.
Parent become child.
Child can't point to parent object. Now, before I run this, I have a question. When I do system.out.println S1, where S1 is now pointing to a Marvel hero object, it's going to call toString, right? Is it going to call toString?
Yeah.
But whose toString? Is it going to call the toString of the Marvel hero? Which I think the Marvel hero toString has that word Marvel and then it has their strength power listed? Or is it going to just call the superheroes toString where it just says so-and-so has this power?
I think it's going to call the superhero string. I think it'll call the Marvel hero.
All right, we've got a little bit of a conflict. All right. So just to make sure we understand the question, it's a parent variable pointing to a child object, legitimately so. Which method is going to get called? The parent or the child? Let's hit run and find out after a word from our sponsor. Ooh. That'd be the time to put my ad in. All right, but anyway, here we go. Last one. Elastigirl has the power stretching Marvel 79. Oh, looks like Alex is right. Okay. Hey, the first time for everything. Roth is wrong. Okay. So, here's the principle. Now, this is something specific about Java. I do not know enough about Python. I can't remember what goes on with C++. I knew it one time, but I can't. But in Java, if you are pointing to a child object, then it's the child methods that are going to get run. Okay? So I'll say it again. If you're pointing to a child object, then the child objects are going to get, the child methods are going to get run. So if the variable points to a child, then the child methods are run. John, does that make sense? Okay. If I were to say S1.attack, is it going to run the attack from the superhero or the Marvel hero?
Marvel hero.
For the Marvel hero, because it's pointing to a child. Yep. Okay. I think that makes sense. That's all well and good. But let's go ahead and make it a little bit more confusing. Okay. Let's go to the Marvel hero class and let's make a change. Let's make a method that only the Marvel hero can do. There's some things that only Marvel heroes do, right? How about fight Thanos, right? That's only something that a Marvel hero would do because in the DC universe, Thanos doesn't exist, correct? All right. Oh, or we could have like, we could just have all kinds of fun with this, but we'll just get it. So public void fight Thanos. System.out.println. I don't feel so good, Mr. Stark. All right. Probably, if I thought about this a little bit longer, I probably could come up with something better, but that's all right for right now. I think that's the phrase. See, I don't have it all memorized like I should, but you know, that's all right.
I think it's Mr. Stark. I don't feel so.
I think it is. That's what I'm thinking. Yeah. Okay. Yeah. All right. So that's what I was wondering. Gonna have to watch it another 2 or 3 times for Endgame just to make sure I get all the references right. Okay. Stark, I don't feel so good. I think it's kind of like a ... kind of thing. So, all right. Something that only Marvel heroes can do. Let's go to Earth, even though he doesn't say that on Earth, but that's okay. Now, if I were to have M1 dot fight Thanos, no problem, right? Because M1 is a Marvel hero. Okay? If I were to say M2 dot fight Thanos, also no problem. Okay? If I were to say S2, well, let's just make it real confusing. S1 dot fight Thanos. Uh-oh. It's not really liking that. Why is it not liking me saying S1 dot fight Thanos?
Because it's specific to Marvel?
Mm-hmm. Because it is specific to Marvel, okay? That's and S1 only has access to the methods in the superhero class, right? But here's what I'm thinking. You know, and I know, and you know, that at this point in the code, S1 is not pointing to a superhero object. S1 is pointing to, which is a Marvel hero object, right? So, I really should be able to call this method. You see what I'm saying? Because it's pointing to an object which has that functionality. So with me so far so good? So how can I force Java to say, hey, I want you to treat this variable like it's a variable of type Marvel hero?
And if loop?
No, not, well, there's a couple things wrong with that sentence. Ifs are not loops, they're decision structures. But you could say if this thing happens to be a Marvel hero, right? Then do this. That would be actually a great way of doing it. But I'm not going to bring the if statement in. I'll just say we'll assume that it is. Okay. But in other code, at some point, I can show you how to check the class. You can it is possible to get the class name. But for our purposes, we know that it actually is pointing to a Marvel hero. So what we want to do is we want to treat this variable like it's one of these variables. And we've done that before. long time ago. And then we did it again earlier this year as well. Does anybody remember when you had a variable of one type, but you wanted to treat it like a variable of a different type? Alex knows. John knows. We had a variable of one type that we wanted to treat it like a variable of a different type. It wasn't in relationship to classes like this. It's actually related to primitives. Let's see if my CS2 guys remember. Hey, programming 2 guys. Do you remember what the process is called when you want to treat one variable or variable of one type as a different type? Casting.
Oh,
Cast as a play. Cast as a play, right? So we want to treat. That's all I want to hear. I just want to hear y'all say the word casting. We would cast an int as a double or a double as an int. Do y'all remember that? And you put the word in front. You put it in parentheses in front. The type in front. That's what we're going to do. What we're going to do. We're going to say S1, but then in parentheses in front of it, we're going to write Marvel hero. So it will cast it as a Marvel hero.
Can't you put M1? No.
I could put M1 dot and I could put M2 dot fight Thanos, but that's not.
Yeah, you're trying to find.
I'm wanting to show you how you can cast a parent as a child object. So I'm going to say Marvel hero is parentheses S1 dot fight Thanos. And what that'll do is that will cast the variable S1 as a Marvel hero. Pretty cool, huh? Open parentheses, Marvel hero. Okay, cannot be resolved to variable. Okay, actually, I need to do one more thing. I need to see whenever we see fight Thanos, we see dot fight Thanos. Everything over here needs to be a Marvel hero type. So that dot is actually taking priority over this casting. So if I want that casting to come first, I have to actually put another set of parentheses around the whole thing. So that over here, Java sees a Marvel hero object, and then it can say dot fight Thanos. And so now, if this works, we should see 3 Mr. Stark. I don't feel so good. All right. Pretty good, huh? All right. So that leads us to another rule, which I have them all of these rules sort of like summarized in another document. I'll show you in a minute. And that is that a parent variable can be cast as a child. So like a parent can act childish and do their childish things. But this is kind of where it breaks down a little bit, because can a child act like an adult? I mean, in real life, yeah, I get a parent, they can play house and stuff like that, but but that's whatever. Anyway, so this kind of breaks down. But a parent variable can be cast as a child, and then you can call methods that are particular to that child. However, with great power of casting comes great responsibility. Okay? Because it is possible that this S1 is not pointing to a Marvel hero. Okay? So for instance, Java will allow this, but you darn well better make sure that this S1 is pointing to a Marvel hero. Okay? Because if it's not, then it's going to try to cast something into a Marvel hero that is not a Marvel hero at all, and therefore will you are then going to try to fight Thanos on something that is not a Marvel hero, and that will result in red lines of death. Observe. S2, which we all know, is Bob the Superfast Builder. Okay? Not Marvel in any way. Java will allow me at compile time to do this, to cast S2 as a Marvel hero. It's like, okay, I hope you know what you're doing. And I hit run. And there's a class cast exception. Superhero cannot be cast to Marvel hero. At Earth, Maine. Okay? So, I don't know. I think it's pretty cool. Like I said, you can cast a parent variable as a child, but you better make sure that it's pointing to a legitimate child object. Otherwise, you'll get red lines of death. Okay. It's some pretty interesting stuff, some pretty weird situations that can arise, and there's probably even weirder ones that I don't even know about. So, let's go, and I think I have a nice list here. 11C, rules for inheritance. Let's see if you agree with all of these statements. Use the keyword extends to designate a superclass. Yep. A subclass inherits all the instance variables of its superclass. Yep, gets all those properties. A subclass can add new public or private instance variables. Yep. A subclass can add new public or private methods. Sure, it can add on all kinds of stuff. A subclass can override or redefine inherited methods. Yep, it can redefine them. It can override them. A subclass can call a parent class method using the super keyword, and then the dot, and then the method name. That's how you call a parent method. A subclass's constructors can explicitly call the superclass's constructors using the keyword super, but it must occur on the first line of the constructor. I don't know if I made mention of that, but that's a rule in Java. If you call the parent constructor, it has to happen on the very first line. A subclass cannot access the private members of its superclass, something we mentioned at the beginning of this class period. A variable pointing to a subclass object will call the subclass's methods. That's what we saw right there. If a variable points to a child object, then the child object's methods are called. Java supports single parent inheritance only. I didn't make a big deal of that, but yeah, single parents only. You only have parent, child. You have grandparents, you know, where a parent and then the child, and then that child is a parent to another one. I think you did some of that in one of them.
I don't think it's working. I'll find out.
Okay. In C++, you're allowed multiple inheritance, where you can have like a mommy class and a daddy class and then a baby class that inherits. But think of, and they have answers to all these questions, but just think of the problems of what if the mom and the dad both have a method and then the child calls super? Who gets called? You see what I'm saying? So I can't remember how C++ deals with all that stuff, but it does. So that's kind of fun. A variable of type parent can point to either parent object or a child object. So the reminder there is parents can point at themselves or their children. A variable of type child can only point to a child object. Children can't point at the parents. And then here we go. A variable of type parent can be cast as a child variable in order to access methods that only the child class has. However, the object the variable refers to must be a child object, or else a runtime error will occur. If you can understand that sentence, you should give each other a high five. A variable of type parent can be cast as a child variable like we did right there, in order to access methods that only the child class has. However, that object the variable refers to must be a child object, or else a runtime error will occur. Alex understands it. Ralph understands it. John, yeah, he understands it. Oh man, you guys are coming over here.
Oh, high five, Rose.
High five, Rose. She gets it. Yeah, she does. If she watches it. So, okay. All right, so that's inheritance. Tomorrow, what we'll probably work on is 11D and then hopefully 11E as well, which will basically be you'll implement yourself, where there are some objects, there are some classes there, and then you can run that stuff. I do want to look at something that Ralph mentioned a minute ago, like an if statement, and so I'm going into thin ice here because I really don't know, but we'll try it out. Let's say if s1 dot get class, that's returns the runtime class of the object. The return class object is the object that is locked by a static synchronized. Yeah, so you can, I think that's the only thing. This right here, get class, you can then say something like dot I don't know the proper way, get name dot equals, oh my gosh, I think it has to be Marvel Hero dot class dot get name. I think it's something like that. Let's see if that works. Okay. But if I do S2, then it shouldn't do it, and it shouldn't give us a runtime error. Yeah, so good job there, Ralph. So what you can do is every class has a get class method, and then you can get the name, and since that's a string, you can compare that to the Marvel Hero class get name property. And this is the code that you would have to do to make sure that if you did the cast, then it was legitimately pointing to a child.
So it doesn't work.
This code right here, this code right here is not executed because S2 is pointing to a Marvel Hero. Right? But just think of it this way: you should smile because even in Red Lines of Death, you are a child of Thanos.
Okay.
All right. That's a little bit closer, right? Okay. All right. The thing is that these kind of jokes only are like legitimate now. Like all future times when I teach this class, they're going to be like, "You're dumb," and that's so last year or 2 years. I mean, you guys are saying that now anyway, but still, I think I can enjoy it. I've never messed with this, but that's pretty cool. All right. Ralph, we've got 5 minutes to start installing Eclipse. John and Alex, if you guys want to start looking at Racehorse and Scheduler, I recommend you do that. Thanks for watching.
Bye.
Everybody say bye, Rosa.
Bye, Rosa.